Hi, I'm Farai and this is my code lab. Today I'm going to start going through all the Ctci questions. I've started a few times but I've dropped it because I lost interest, but I'm going to pick it up now. So we're going to start off with chapter 1 and the first question is int unique. Implement an algorithm to determine if a string has all unique characters. So let's see, what word has all unique characters? I think there's an example. Not sure why I'm doing this rigmarole. Unique. Unique. That is all unique characters. So what do you know about them is the count is that you just make a frequency table, so you 1 and 1 I 1 Q 1 U. Oh wait, no, it's not. So 2. So that's not unique. So what is unique is, right? So A1 and S1. So it is unique. So the way I'll do this is I'll create a hash map to record the frequencies. So let's write that in. Let me just use blue. That'll be much better. So is unique. It's is unique. Does it matter? Yeah, kinda. But str, and then chars is equal to a map. Then for that I equal 0, then I is less than str dot length, then I plus plus, then what we're going to do is if chr s, then str I, then return false because that's not there, and else chrs stri is equal to true. Then we close that and we return true. Nothing to it, so let's try it out with unique. So there's our chrs. So we start off. Is U here? No. So we just put U and true. Oh wait, I didn't make a frequency table, but it's not necessary. Is N in there? No. So N is true. Is I there? No. So we added in, it's true. Is Q there? No. And we added, so it's true. Is U there? Yes. Yes, it is here. So we're going to return false. And none? No. Bread. Yeah, bread. So, is B there? No. So true R, no. True E, no. True E. true, D, true. So since we added that, then we just return true. All right, that's it. Let's go to the solution, not as we need it, really. Oh yeah. Oh yeah, the other part, it mentioned something about what if you can't use additional starter structures. So I think you can use an AND or an XOR or something like that, but I haven't learned much about bit manipulation. In fact, I think it might be a chapter here, so I'll have to learn what that is before I tackle it. So that's something to bear in mind. So let's look at the solutions they have. Yeah, we don't care. We're using a hash map. So what they're doing, we're doing the same thing. It's just that she made an array with 1, 2, 3, 4, 5. She made an array corresponding to each character. So you just use the character code and then you put it there. And what was our runtime? Linear time and linear space. Then a bit factor would just be linear time and constant space. Oh yeah, and then they said sorting is another option, but that's in again. So, all right, that's part 1. Now 2, check a permutation. Two is permutation. So, firstly, given 2 strings, write a method to check if one is a permutation of the other. So, how can we do this? What do we know about a permutation is permutation has the same letters rearranged. Right? So let's say it's what is a sorry. What is a permutation or what? Noon. And no. Yeah, so it's a permutation. So you see they have the same letters just rearranged. So what we can do is, one option would be to sort the words and could like sort the words and check if they're equal. So just do N, N, O, O, N, N, O, O. The other option would be to make a frequency table and count how many letters are in each. So N 202 202. Sorry, as you can see, I'm really here early. I mean, I don't have time to do anything else any other time. So I like the second one. So we find the function permutation S1, S2. Oh yeah, and they also have to be the same length. So what we can do is, if dot length is not equal to S2 dot length, then we just return false, right? thinking of building a frequency table of one, but all right. Did I mention I had things updating? So gosh, that would have been a mess. So we can update these frequency tables simultaneously, right? Yeah. So because they're the same length, so let I equal 0, I less than s1 dot length, I plus plus, and then what we're going to do is that so that's our frequency table. All right, so if S1 I CHRS S1 I it's then CHRS S1 I plus equal 1. Else CHRS S1I is equal to 1. Likewise, if CHRS S1I then CHRS S1I is minus equal 1. I don't know why you didn't explain the approach. So I'm just trying to see. So if they're the same number of letters, then when you find one here, so you add when you find in the first one, and you subtract when you find in the second one. And then after that, you're going to loop through and cross them out and see if any of them are not 0. Because if they're not 0, that implies that it's not, that the letter counts are not equal. So that's why we're doing plus up there. And then else CHRS is not S1, man. Whoops. Wait, why aren't you an object eraser? S2 I is equal to -1. Right? And then that's cool. And can you be clever? Because I don't really want to do all that indexing stuff, so for freak in CHRS dot values, dude, languages have convenience features, get over it. And if freak is not equal to 0, then return false. Then return turn true. All right, so let's do bright and let's do what words can we do? Tent, net. All right, so here's our CHRS. So T is not there, so it's 1. Then that N is going to be -1. Then we see an E, so that's 1. Then we get E, that's 1. Then we see another E, so that's -1. Then we see an N, that makes it 0. Then we see a T, that makes it 0. Then we see an N, a T, makes it 1. And then that, which makes it 0. So that's all zeros. And we loop through, and then T is 0, N is 0, E is 0. So this is true. What about boot and turbo and tops? Okay, so B is 1, T -1, O is going to be 1 -1 is 0. And then another O, so this is 1. Then B, that's 0. Then S is going to be 1. And T is going to be 0. So you have 0, 0, 1, 1, and then that is false. So yeah, let's look at our solution. All right, sort the strings. Yeah, that's what we discussed. Then check if two strings have identical character counts, which is what we did. So, yeah. Yeah, it's pretty much the same thing we did. All right, so URLify. Where here we need to write a method to replace all the spaces in a string with %20. You may assume that the string has sufficient space at the end to hold additional characters, and that you're given the true length of the string. I'm not implementing that in Java, so I don't have to care about that. So, let's figure this one out. To John Smith, and then that's what, 1, 2, 3, 4. Let's look at the example here. So, Mr. John Smith. 2, 3, 4. That just becomes Mr. %20 John %20 Smith. Math. Right. We're told the actual length is 13, so that's 0, 1, 3, 4, 5, 6, 7, 8, 13, yeah. So we're given the true length. So, how do we do this? Sure, it's a matter of just trying to move things on. So I would say back to front would help us here. So we'll start at the back, right? So we'll need to keep two ends. So we'll need to keep this one, which is true end, and the actual end. I don't know. So then, like, we have these 2 pointers. And then if the true end, what I call these? Yeah, if the true end is not at a space, then we can safely move the character over to the actual one, and then we decrement them both. Then, once we hit a space, right, once we hit a space, we fill it with 0 to %. Yeah, like once we get to here, like after Smith S here, right, our end is here, then let's make a simpler example. So let's see, to do, then space, and then the actual length is 1, 2, 3, 4, 5. Okay, right? So we'll need the end and true end. So yeah, let's just do TE and E, right? So then if TE is not a space, we just let's do 0, 1, 2, 3, 4, 5, 6. Okay, so that means our true end is equal, let's do this, our true end here is 4, and our end is at 6, right? So now if it's here, then what we do is we just move it over, and then we decrement both of them by 1, and then we now add this one at 3 and 5, so 3 and 5, so then that means we just do D, and then we decrement by 1, then we get to 4, and then we get space, and then this we need to do at the character it's a 0, at the -1 it's 2, and the second one it's percent. Let me just align these. It's a 0, it's a 2, it's a %. So that one is still decrements by 1, but this one decrement by 2. No, we decrement by 3. And then we get 1, 1, and then you just do this, and then 0, 0, and then do that. So let's put this into code now. Function simplify. I think there's more to it than that, buddy. All right, so TE, that's our true end, is equal to T(n) minus 1, then E is equal to ST length. And while wait, this is in place, right? You tell me it's in place. Oh, it's up to the language to say if I can do it in place, but oh God. Jeez. Ooh. Okay, so while I'm trying to figure out when to stop. While TE is greater than or equal to 0 and E to 0, then if str te is equal to space. No, that's not what it actually would be. But so if it is a space, then what we're gonna do is then str E is equal to 0, str E minus 1 is equal to 2, str E minus 2 is equal to percent, and then E minus equal to. Do I need an else here? I'm just wondering if this should be my last question for today, because I'm breezing through them. So, I'm just thinking, should there be an else? Else, what do we do? str not str, man. Word. Oh, word. Word. Word E is equal to STRTE. Okay, yeah, so here, so and then after that we just do TE, E, right, and then what we're going to do is return word join with nothing. And yeah, so let's do to do again. So running through our code with 2 space 2. So let's just have our array of length 1, 2, 3, 4, 5. Right, then TE. Ah shit, wait, no. Oh yeah, thankfully I'm doing this, eh? Oh no, I was right. Wait, to do. Oh yeah, I was right. What was I doing? So it's TO space T2. Shoot. TO space DO. Shit. Yeah. To do. Then space. 1, 2, 3, 4, 5, 6, 7. Yeah, so 1, 2, 3, 4, 5, 6, 7. Yeah. So then TE is equal to this would be 5, right? It would be equal to 4. Then E will be equal to 6, right? So these are both greater than or equal to 0. So is E is TE. So let's do 0, 1, 2, 3, 4. Is 4. That no. So we put a 0 there. Oh, no, it's double equal, not single equal. Else word E is equal to TE, which is that, then TE minus 1. It's, what the heck? Let's do it like this. T, E, and E. Oh, shoot. T is 4, the actual end is 6. So, yeah, then we just decrement by 1. and 3, 5, and then same thing is TE3. No, that's a D. So we go 2. For some reason I'm thinking of the emotional damage meme. Not saying this is emotional damage. Well, it will be at some point. Then 2, 4. Yeah, there's a space here. So what we're going to do is at E, that's 4. So 0, 1, 2, 3, 4, 5, 6. 4, we're going to put 0 minus 1. It's going to be 2. And then percent. Minus 1 minus 2. Minus 2, which is 2. Right, and then we're going to subtract by 1, so it's 1, 1. Then we're going to go O, and 0, 0. And then that's going to be T, and minus 1, minus 1. And that terminates, and we get 2% 22. And that is what we get. Contemplating should I do this last one, but let's look at the solution. Because I literally have time for one more, or I can just pack up and get to work. So URLify, a common approach is to edit the string starting from the end and working backwards, and we can play with the buffer. This is what we did. We'll use this approach. Wait, why can't we just build a string from scratch? Yeah, and then you count the true spaces. Wait, what do they do? So first we count the number of spaces we triple, then we see how many extra spaces we have in the final string. Then we actually edit the string. So I'm just thinking, is the last part really necessary doing what we did? Because the string has all the extra spaces, so we could just get the length of the string. The string has the buffer at the end. Unless, did it say it corresponds to sufficient space? Yeah, that's... I would like to say I succeeded, but I should have questioned what we meant by sufficient space, because sufficient could be meaning like that to-do could have like 3 billion characters at the end. But then in any case, why do we need to do this silly math? We could just do it differently. Anyway, I barely passed that. Alright, so should I do 1.4 or should I just come to it another day? When we check the palindrome of a permutation. This one we can do pretty quick. So 1.4 is palindrome permutation. So oops, I didn't show you, my bad. Alright, so given a string, write a function to check if it's a permutation of a palindrome. A palindrome is a word then phrase that is the same forward and backwards. Actually, no. I will just leave it here for today. And we did 3 questions successfully. So yeah, that's it. We did is unique, check permutation, and URLify. So thanks for watching, and I hope to see you next time.